Language is our most astonishing faculty. We don't just use speech as a basic communication tool. We were able to create tons of completely different linguistic systems, each with its own unique set of sounds, intonations, and grammatical structures. But how did we manage to do that? The answer lies somewhere in our brains. What makes language so interesting is the fact that its functions can be mapped in the brain. Our ability to speak is lateralized to the left hemisphere in roughly 93% of people. The most convincing proof of this was given by Canadian neurologist Yoon Vada. Vada developed a technique, which is now called the Vada procedure, that enabled him to study the activity of a single hemisphere of the brain by deactivating the other. He injected sodium amytal, a fast-acting anesthetic, in one of the two carotid arteries of a patient and waited for about 10 minutes. In those 10 minutes, the bloodstream took the anesthetic to the corresponding hemisphere of the brain and paralyzed it. Vada then asked questions to his patients and witnessed two different scenarios. If the right hemisphere had been paralyzed, the patient could perfectly answer, while if the left hemisphere had been paralyzed, the patient couldn't utter a single word. Vada correctly concluded that the left hemisphere was with no doubt dominant for speech. Important breakthroughs concerning brain areas that are critical for language come from the study of aphasias. The term aphasia indicates a condition of language impairment which results in the inability to express or understand language. The first type of aphasia to be described in history is called Broca's aphasia, and people affected by it have difficulty speaking, even though they can understand both written and spoken language. Paul Broca was a French neurologist who, in 1861, became interested in a patient who could only say the word tan. Patient tan would make all sorts of gestures while repeating the word tan to try to communicate. When patient tan died, a biopsy of his brain revealed that he had a lesion in the frontal lobe, and more precisely in the inferior frontal gyrus. This area of the brain is now called Broca's area and is associated with speech impairment. A few years later, a German neurologist, Karl Wernicke, studied a patient who was unable to understand language but could speak fluently, even though his speech often made no sense. When Wernicke examined the patient's brain, he discovered that he had a lesion in the temporal lobe, and more specifically in the superior temporal gyrus. This area, which was subsequently named after him, is associated with language comprehension. But what if you know more than one language? What if you're bilingual? Are both of your language abilities mapped in the same place? Before we try to answer these questions, we need to draw a distinction between early and late bilinguals. Early bilinguals are people who learn their second language early in childhood, usually before age 12, while late bilinguals are people who are exposed to their second language after age 12. Studies with functional neuroimaging have shown that in early bilinguals, the two languages overlap both in Broca's area and in Wernicke's area, while in late bilinguals, the two languages still overlap in Wernicke's area, just like early bilinguals, but unlike early bilinguals, they are clearly separated in Broca's area. These findings have led to insights about what happens when a bilingual person has a stroke that produces aphasia. Depending on the age of acquisition of the second language and on where the stroke happened, it is possible to predict whether both languages will suffer equally or not. So, as we have tried to show, human language is indeed brain stuff, and most of its secrets have yet to be unveiled. Would any of you care to make the next discovery?